On example 2, once again, we can see that the two angles that they've given us are corresponding angles, okay? Now, based on our corresponding angles postulate and the fact that these two lines are parallel, so parallel lines imply that corresponding angles are congruent. Okay, this would be your reason in your proof if you were to do a proof. Okay, so since they're parallel, I know that these two angles are congruent. So I know that 5x minus 30 has to equal 2x plus 60. Okay, because we know that corresponding angles, when the lines are parallel, are congruent. From here, I'm just going to solve the equation. And x equals 30. Okay? So in this case, x equals 30. You could again double check your answer. 5 times 30 is 150, minus 30 is 120. 2 times 30 is 60. 60 plus 60 is 120. So both of those angles are 120 degrees. If you plug them back in and you get different answers, then you've done something wrong. That's the way you should be checking your answers. From here, let's move down and look at a proof. Now in this case, we're going to prove the alternate interior angles theorem, okay? So, in order to prove this, we are given that line L is parallel to line M. Now what you'll do in real life, that line L, is you'll use a cursive L so that you know that it's an L and not a 1. Do your parallels slanted. The computer just does them straight up and down to line M. Your lines will always be written with cursive letters, okay? Now, this is given. You can just copy all of this down on notebook paper. Just draw the pictures or write this out, okay? So now, to denote that those are parallel, you're going to put little arrows on both of those lines. Remember, we always mark our picture. So line L is parallel to line M. We're trying to prove that angle 2 is congruent to angle 3. Well, the first thing, if we already know, because we've been given by the corresponding angles postulate, and that postulate is a statement accepted as a fact. So we know that angle 1 and angle 3, those are corresponding angles. And since the lines are parallel, those corresponding angles will be congruent. So we can say angle 1 is congruent to angle 3 because parallel lines imply corresponding angles congruent. Okay, that should be a congruent symbol. So that tells us angle 1 is congruent to angle 3. Well, from here you can see that angle 1 and angle 2, those are vertical angles. So if we already know something about angle 1, well, now we know angle 1 is congruent to angle 2 because vertical angles are congruent. And you can just write that out. Vertical angles are congruent. You may also write definition of vertical angles, but you need to make sure you understand what that definition of vertical angles means. Well, now, if angle 1 is congruent to angle 2, and I'm going to mark my picture, I can see from my picture that all three angles are congruent. I can also use my transitive property to say, since angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3, then we now know that angle 2 is congruent to angle 3 by transitive property of congruence. Okay, now we could not use alternate interior angles theorem because you didn't know that yet. Now we can see that when lines are parallel, alternate interior angles are always going to be congruent. Okay, now you may use this theorem, alternate interior angles theorem, that you wrote down in your theorems list already, to prove any other proof because we've already proved it. Now when the lines are not parallel, this doesn't work. This only worked because lines L and M were parallel. So if the lines are not parallel, you can't make any conclusion about angles 2 and angles 3. From here, we're going to use what we just proved to find the measure, to find angle x. Well, in the same way that alternate interior angles are congruent, alternate exterior angles are congruent. Since they're alternate exterior angles and parallel lines imply that alternate exterior angles are congruent, then I know that this angle and this angle must be congruent because they're on opposite sides of my transversal and they're on the exterior of my two parallel lines, which our picture tells us they are parallel. So I know that 136 degrees equals 4x degrees, 34 equals x. And again, you can plug that back into your 4x. 4 times 34 should give you 136 to show that they're congruent, and check your answer. From here, on example 4, this one is going to use your same side interior angles theorem or your corresponding interior angles theorem. Same side interior and corresponding go both ways. So in this case, they're supplementary. If you set these equal to each other, they will be wrong. Reason being is because isn't this angle congruent to this angle right here because those are alternate interior and we can see that the lines are parallel? Well, this angle and this angle form a linear pair. If those form a linear pair, these two angles are supplementary. Now, since these two angles are congruent, then these have to be supplementary by your congruent supplements theorem. If an angle is supplementary to another angle, then it's supplementary to any congruent angle, okay? From here, the first thing you're going to do is combine like terms. 14x and 19x gives you 33x. So 33x plus 36 plus 12 is 48 equals 180. And x equals 4. Okay? Once again, you could plug that back in, check your answer. These two angles should be supplementary. From here, we have a significantly more complicated picture. You can see we have 3 parallel lines and 2 transversals. Okay? When lines are parallel, your transversal, you're going to typically use your non-parallel lines. Well, we want to find x and y. Well, we just look at those two angles. You can see these lines aren't parallel, so you don't know anything about those relationships, that relationship. You know that they're alternate interior angles, but since the two lines that they're on alternate sides of, or that they're on the interior of, are not parallel, you can't make a statement to say those are congruent. You just don't know it, okay? The only time that works is if they're parallel. So we know that these two lines are parallel. It's noted, okay? You also know that these two exterior lines are parallel, okay? So if you were to cover up these bottom ones, which I'm having a hard time doing all the way, you can see that this parallel line, or let me give you another one. This line right here, that's going to be one of the parallel lines. And we're also looking at this line right here. Those are your parallel lines, and this right here is your transversal, okay? Now, you can see on those two parallel lines and this transversal, 72 degrees and 4x plus 3y, those are alternate interior angles. So since the lines are parallel, then alternate interior angles are congruent, so you could say 4x plus 3y equals 72, okay? It should be a 7. Let me fix that. Now, you have 2 variables, however, so you're not going to be able to solve that one just in one step. So from here, we also want to look at the other relationship we know, which we can see these two angles, right? Now, the bottom ones, if we ignore this 72 and we change and make this line now our transversal, and this line our other parallel line, and you can see that if we cover up, let's see, if we cover up this corner, and we cover up the top, you can see two parallel lines, and, oops, let's see something. You can see your 2 parallel lines and your transversal, and we see that these 2 angles are corresponding angles, so we know that they equal each other. So you could say 9x minus 3y equals 84. Okay? Well, in order to solve these, you can see we're going to need to use a system of equations. Okay? Now, to use a system of equations, you can use substitution, elimination, or graphing method. Okay? The easiest one here is elimination. If you remember, you can put the two equations, if they're lined up, our x's are lined up, our y's are lined up, and our equals, and then our constant. They're both in standard form. From here, we can just solve them. Okay? So what you're going to do is you're going to say, let's delete those. You can add straight down. And our goal is to eliminate a variable. Well, our y and our 3y and our negative 3y, they're going to cancel out, divide out to 0, or add to 0. So we have 4x plus 9x gives us 13x. 3y minus 3y is 0, equals 72 plus 84 gives us 156. To solve for x, divide by 13, divide by 13. X equals 156 divided by 13, which is 12. Now, if x equals 12, I plug that back into either one of my equations. I'm going to plug it into this first equation and say x instead. So you would say 4 times my x value is 12 plus 3y equals 72, y equals 8. So your solution would be 12, 8. And so if you plug in 12 for x, 8 for y, that would be your answer. Okay? From here, we're going to do just the last set